All right, 7th graders, we're going to go through some practice problems from lesson 7-5. And this is from your homework assignment. The problems with solving equations with variables on both sides of the equation. So the first one you did for today was number 4. X minus 7 equals 2x minus 6. X minus 7 equals 2x minus 6. Now, once again, we're working with problems that have variable terms on both sides of the equation, numerical terms on both sides of the equation. And so, what's our first goal when we're solving these? What's our first goal? Noah?
To get 2x alone.
Get 2x alone. Okay, that's part of it. Get to get x on one side. Yeah, to get all x terms on one side. What's the other goal? Kira?
To get all numerical terms.
Yep. And to get all numerical terms on the other side. All right? That's the first thing that we need to do when we're solving this. So now how do we do that? Whenever you're having to move terms or get rid of terms on the sides, that's always adding and subtracting. It's really just adding. You're either adding positive or you're adding negative. Okay? So you always want to start with adding. Adding something. Okay? And you're going to add to remove it. You're going to add to get rid of it. So what kind of number are you going to add? Joey?
The opposite.
You're going to add the opposites. Right, you're going to add opposites to things. So let's start with this one. What can you add to this to remove something in order to meet our goals? Chase?
Plus negative x for the...
Oh, good. So plus negative x to this side. And that removes the x terms from this side, right? So we have 0 plus negative 7 then. Now, whenever we add to one side, you have to add the same thing to the other side. And if you add a negative x to 2x, you're left with 1x. Yep. And you still have a negative 6, don't we? We want to insert plus signs so we can identify what kind of number that is. Now what? Troy?
Add 6 to the negative 6 to the
Good. Add 6 to this side. That still leaves x on the right side, and that solves it, doesn't it? Because we have 1x. So x equals negative 1. Okay? Does that make sense?
Yes.
Good. Let's go through number 6. 3a equals a plus 22. Now what? What's our goal again? John? Get rid of the plus 22. Okay? So what are we trying to do by doing that? We're going to get rid of it on this side and get this a by itself? Okay. So we had negative 22 to both sides. Now what do we have?
But...
We're left with a
You did that wrong.
equals, it's not wrong, let's just see what happens here. Okay?
Why is this way?
Oh, you did?
Okay.
Do you want to back up? All right, let's back up. Back up. Reverse. Whoops. Now what do you want to do instead?
Okay, so subtract the A from the A on the right side.
All right, let's subtract this A
And then take A away from 3A.
and add a negative A over here. Yep.
And so then that would be what? 2A equals 22.
Yeah, good. Now we've got the variables on the left side, the numerical term on the right side.
And then just I'm going to divide. So 2A divided by 2 and 22 divided by 2 would be A equals 11.
Good. Yep,
First try.
good. Number 8, next one. Now, the key in this class is you're always looking at patterns, especially a lot in math. You're looking at patterns. How is that problem the same as the other ones that we've done? Maybe the numbers are different. Maybe the variable is a different variable. But notice the procedure we're using is the same. Okay? It's solving problems, and there's more than one way to solve the problem. But the procedure stays the same. Look at this one. See if you see a similar pattern. 4W plus 8 equals 6W minus 4. Nikki?
You would add 4W.
Okay. So let's get rid of the W's on the left side and by adding negative 4W. And if we add negative 4W on the left side, you have to add negative 4W on the right side. That leaves what? 2W plus negative 4. Now, Noah?
What? I'm not raising my hand.
Oh yeah, you were.
No, I'm not.
What would we do next? I just called on you.
Wow. Okay.
Yeah, I can do that.
Fine then.
impressive,
Be
isn't
that
it?
Watsky power.
Yeah.
Be that way then. Okay,
Okay.
then you do plus 4.
Good.
And
We
then
have
you do.
four. Get rid of the 4 on the right side, right?
Yep.
And
Then you do plus 4 on that side too.
yep.
And then that will equal 12. And then
12 equals what?
12 equals 2W.
2W. Right. Plus 0, but we don't have to write that now because we know that it just gets rid of that, right? Now what?
W equals 6.
How do you gotta
You
prove
divide
it?
by 2.
Divide both sides by 2. Yep. So W equals 6. Notice I said you have to prove it. Okay, how do you prove it? Dylan? You show your work. Yeah. Showing your work proves your answer. We don't have to guess then, because we're proving it. Okay? Number 10.
What if you got negative 6 by adding plus negative 8 to the 8, and adding that to the negative 4?
Good question. That's why I said there's more than one way to do these problems. But if you follow and you add and subtract correctly, you're still going to get the same answer. So he's asking, well, what if we did this the other way? What if we got rid of the 6 W's on this side?
No, I did both on the same side. I think that's like,
Okay. So it's,
I did plus negative 4W to both sides, and I
okay.
did plus negative 8 to both sides too.
All right, let's see what happens here then. If you get rid of the 4 W's on this side, so you have 8 on this side, and 2W, because we added the negative 4 W's again, plus negative 4, right? Now, what if we get rid of the 8? Add negative 8. What's left on this side? 0. So that means 2w equals, plus negative 12 equals 0. Is that true? It's true.
No, yeah.
It's true. This is still, if we put a value for w here, it equals 0 because we know now that w equals what? 6, right? So 12 plus negative 12 equals 0. But does that solve the equation for w? No. No. Because what do we have? Do we have the variable terms on one side and the numerical terms on the other side? No, we still have them both on the same side. We have to get rid of this one. So what would you have to do from here to solve it?
You have to add 12 to negative 12.
Yep. And?
And to the other side.
Right.
Oh,
See, you're not. Maybe you did this wrong, but do you need to start over to solve it? No, you don't. You don't have to start over and say, oh, I messed this all up. You just took a little detour. Okay? You just made a wrong turn. You just make another turn and you're back on track. You don't have to go back to your house and start over.
You don't?
No. Just use the procedure. You still have 2w equals 12 then. Right? That's the cool thing here. Alright? Because you're solving this using the procedure. Not a set certain way, or not you add this number here, you have to do that. You have to follow the procedure. Or you have to play by the rules. Okay? Number 10. How is 10 different? There's an extra step in that one.
Because there's 3 B's.
B plus 18 equals 4b. What's the extra step? How does this one look different? Kira?
Well, you would have to like do add the B's to make
On
on
the
the left.
left side, right. What do we call that procedure step? Adding like terms, yeah. If you look back in your notes, it first says, the first thing it says to do is to add like terms on each side separately. Kind of like simplify each side separately. Okay? And then solve it. Then start moving the parts around to get the variables on one side and the numbers on the other side. So this is 2b plus 18 equals 4b, right? Then what, Dylan?
Subtract 18. Or 2b.
Subtract 2b,
Yeah.
add negative 2b to positive. What does that leave us on this side?
18.
18, yep. And what do we have to put on this side over here?
Negative 2b.
Negative 2b. So what do we still have?
2b.
Yep. Divide by
2.
and
Equals
b
9.
equals 9.
That's 9 equals b.
9 equals b. B equals 9. Yep.
Same difference.
I'm going to assign 12 through 24. But, well, no, actually 11 through 20 for all. But I want to go through number 12 with you first. Because number 12 has something different in it. 7a equals 2 times a minus 10. what does this one have in it that the other ones didn't have? Chase? The distributive property. Yep, it has these parentheses. This means 2 times a minus 10. 2a minus 10s. Alright? One of the ways to think of 2 times a minus 10, class, show me slant. That means look at me, I'm talking here, and I'm showing you something up here. Okay? One of the ways to think of 2 times a minus 10 is to have 2a minus 10s. Or 2 a's and what? What's negative 10 plus negative 10? Negative 20. Alright? Now we get the same thing by with what? The distributive property. Using the distributive property. Distribute the 2. 2 times a is?
2a.
2a. 2 times negative 10 is?
Negative 20.
Negative 20. Remember, addition